So 1.4 is the shifting, reflecting, and stretching of graphs. And so the expectation in precalc is that you will have kind of a family of functions somewhat memorized. So if I talk about absolute value, you're all going to know some sort of V-shaped graph, and then we can do things to that graph. So as you look through this, these are the functions that, as precalc students, we do expect you to know. So the first one, linear, we should be very comfortable working with linear functions. What happens to them when we add or subtract numbers. The absolute value, which we refer to as V-shape for the graph. We've been working the last couple days when we've been talking about domains. We've done a lot with the square root graph. The parabola coming out of the quadratics, the U-shaped graph. So what's happening with those? The cubic, a lot of times we refer to those as S-shape. And then this one, the rational functions, there's a top / bottom. And the other day we looked at it because you don't want 0 on the bottom. So these are the graphs we expect you to kind of know and understand. If we just talk about them, you can create a mental picture. So when we talk about vertical and horizontal shifts, a vertical shift upward is going to happen when it's this plus a constant, what I call outside of the function. It's a number that can just be placed at the end of an equation. So an example would be this x squared plus 5 graph. Moves a parabola, I guess. I'm not sure. Moves a what graph? What? That doesn't make a lot of sense. What I would just say is this moves up 5. So you would take the U that's on the page and you can just move every dot up 5. So in your groups, I want you to go ahead and fill in what you know about it. If you don't know what's happening, take the original graph like the x cubed or the square root or the absolute value, type it in without the plus or minus number, and then type in the new one that's there. See what's happening and just write it down. So then this one, the vertical shift down, right? -2, it's at the end of the function, so that one goes down 2. And then we have to be a little bit more careful because when you place what I call inside the function, so the plus or minus is happening inside, where normally we'd see just an input, so it's inside. It's actually the opposite of what you see. So -6 actually moves us to the right 6. And the +1 here actually moves me to the left 1. I don't know how much you really have to memorize because with graphing calculators, you guys should be able to type in the original or parent function and then the change that's happening, and you should be able to visualize it or see it on the graph anyway. So we're going to go ahead and look at some of these things here. Again, write them down. Just tell me if it's going up, down, left, or right. You know, up 10, left 10, whatever you're doing. So at home, people would pause the video and they would come back to see the answers. So here would be your answer. This one is down 2, left 3, right 1, up 3, right 5, and down 1. So hopefully you got those. But again, in this type of mode, you could actually pick a function. So if you didn't know by this notation, for instance, the f of x, you could make f of x equal to x squared. And then if I just look at this example, I would write x minus 5 is what they want as the input. So I put x minus 5 in there, minus 1. And so this graph would be our basic one here. And then if I went to the calculator and actually graphed this one, it would go down 5, or down 1 and right 5. So you could go to your calculator and actually type it in and see how it's moving it. So you can kind of prove to yourself what's going on. Okay, so sometimes we may have to work it backwards. And so both of these graphs are, what type of graph? How would you describe them? Parabola. They have the U shape. So we should know that it's some sort of x squared graph. So just quickly in your groups, this one they're calling g of x. So write a g of x equation for me. This one they're calling h. Write an h of x equation for me. And then what you should be able to do is on your graphing calculator, type it into y equals like y1 and y2, and make sure that these are the two graphs coming up. So you should be able to check your own answers. So coming back to it now, we should be able to, this is just up 4. So it's my x squared plus 4. Sometimes you might see, sometimes our textbook will put the 4 in front. It's the same thing, whether 4 is in front or 4 is at the end, it's a shift up 4, because it's not inside the x squared. Over here, I would say this is down 1, right? And it looks like left 2. So when I do this one, I'm going to put a parentheses and go x plus 2 squared. Plus 2 is the opposite of what we're seeing. So if it's going left, you have to say plus 2. And then down 1. And again, you can go to the calculator and type those in and make sure you're seeing a graph that does that. So some reflections. They talk about the reflections here. A reflection over the x-axis. All the difference is that you take the new function would be multiplying everything in your equation by a -1. So you multiply everything, and it'll flip it top to bottom, bottom to top. So basically all your y values switch sign. All your outputs switch sign. If you have a reflection in the y-axis is similar to our even function that we talked about yesterday. Everything flips on the y-axis. So x and negative x produce the same thing. The butterfly fold, I guess, is what you could call it. So we're just going to write an equation for these things. Basically what we've been doing. So you might want to grab your calculator. So think about how you're going to move these and how you get them to be that shape. So come up with your equation. And again, you're going to be able to go to your calculator, type it into y1, and verify that you have the same graph. So do that now. So this one is flipped. Most of you would say it's flipped, is what you call it. And that's what this negative is doing in front of the x squared. And then it was up 2. So negative x squared plus 2. That gets it to go up 2 and then open downward direction. And this one has that same flip. This one means it goes right 3. So those should be your two equations that you're writing down. All right, so right now they don't want you to just type it in and use your calculator to get it done. It should be pretty easy. So we want you to kind of visualize what's happening. So our basic square root of x graph, does this. Starts at 0, 0, just kind of goes up slowly, but goes out to the right forever. What's going to happen if I put a negative sign in front of it? So I would still, order of operations, I'd still plug my numbers in. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. That would be our normal graph, but now each time I get done, I multiply by -1. So when I put x is 1, square root it, I get 1, but now it becomes negative. Put in the 4, square root it, I get 2, but now I'll multiply by the -1, I get -2. So now my dots, they want you to understand your dots are down here. And so you get what most of us would just say, we flip it. The up to down flip. Everything that's above goes down. Everything that was down starts coming up. Whereas this one, because the negative is inside now, what x values can I use? I can put 0 in. What's the square root of -0? 0. Give me another number that is nice. You want to kind of 16. If I put 16 in, it's already got the negative, and now when I put 16 in, can you take the square root of -16? No. Give me another number that's going to be nice. -9. So now the negative is there. Now I'm inputting -9. So what's the negative of -9? +9. So what's the square root of +9? 3. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, I can go up 3. So I have 0, 0, 3. What about -4? 1, 2, 3, 4, negative. We'd be at 2, 1, right? So when the negative goes in front of the x, which is inside the function like that, it's the right to left flip. All the y values stay the same, you just go to the negative x value. So in groups, don't use a calculator, come up with this graph. So here's what's going on. Left 2. Left 2 and an up and down reflection. So the +2 inside the function means everything goes to the left 2, and then we reflected it. Because here was the original, right? We're going here. And then it gets shifted left, and then everything reflects down.